Hey guys, this is DG. Today we'll learn the difference between circuit switching and packet switching, or circuit switched networks and packet switched networks. So let's start. Suppose there are two restaurants, A and B. Restaurant A accepts reservation while restaurant B does not. If I want to go to restaurant A, I will have to book a table. So when I arrive at the restaurant, I can immediately be seated and can order my meal. On the other hand, restaurant B does not accept reservation. So when I arrive at the restaurant, I may have to wait in queues before I can be seated. Circuit switching is analogous to restaurant A, which accepts reservation. On the other hand, packet switching is analogous to restaurant B, which does not accept reservation. That is, in circuit switching, resources are reserved for the communication session. On the other hand, resources are not reserved in packet switching. In a computer network, the devices are connected via communication links. Every link has a maximum rate at which it can transmit data. For example, 1 Mbps. It is called the link's transmission capacity. For data transfer, the transmission capacity of the link is shared among the devices present in the network. With circuit switching, all connected devices get a constant transmission rate. For example, if there are 4 devices, every device gets a dedicated transmission rate of 250 kbps. That is, circuit switching pre-allocates the transmission capacity of the link regardless of the demand. Even if the device is not transmitting data, it has the dedicated transmission capacity reserved that cannot be used by any other ongoing communication. On the other hand, packet switching allocates the transmission capacity based on demand. If there are 4 devices present in the network, but only 2 devices have data to transmit, then the link's transmission capacity is shared among 2 devices only. So, packet switching offers better sharing of link's transmission capacity than circuit switching. Packet switching is more efficient than circuit switching because if one sender to receiver pair is not using the resources, then it can be used by any other ongoing communication, which is not the case with circuit switching. Let us understand the 2 points in more detail with example. First point is packet switching is more efficient than circuit switching, and the second point is packet switching offers better sharing of the link's transmission capacity than circuit switching. Starting with the first point, why packet switching is more efficient? Suppose users share a common link. The transmission capacity of the link is 1 Mbps. Every user remains active for 10% of the time and transmits data at the rate of 100 kbps. For the remaining 90% of the time, the users remain inactive and do not transmit data. With circuit switched networks, the transmission rate of 100 kbps must be reserved for all users. Since the transmission capacity of the link is 1 Mbps, so the number of users that can be supported is 1 Mbps divided by 100 kbps, that is 10 raised to power 6 bits per second divided by 10 raised to power 5 bits per second, which is equal to 10. So, circuit switched networks can support 10 users simultaneously. With packet switching, the probability that a user is active is 0.1 because each user is active for 10% of the time. Suppose there are 35 users. Therefore, the probability of having 10 simultaneously active users can be found by using binomial distribution, where x ranges from 0 to 10, p is 0.1 and n is 35. It comes out to be 0.9996 approximately, which is the probability of having 10 simultaneously active users. Therefore, the probability of having 11 or more simultaneously active users is 1 minus 0.9996, that is 0.0004. When the users who are transmitting data are less than or equal to 10, the total arrival rate of data is less than or equal to 1 Mbps, which is the transmission capacity of the link. Hence, the data from users flow through the link without any delay, as in the case of circuit switching. when the number of simultaneously active users is more than 10, the total arrival rate of data is more than 1 Mbps. Since the transmission capacity of the link is 1 Mbps, so the output queue begins to grow until the incoming data rate goes below 1 Mbps. However, the probability of 11 or more simultaneously active users is 0.0004, which is extremely small. So, packet switching or packet switched network offers the same performance as that of circuit switching, along with supporting 35 users, which is more than 3 times of the users supported by circuit switched networks. Now, let us start with the second point, which is packet switching offers better sharing of links transmission capacity than circuit switching. Suppose out of 10 users, only one user is active and suddenly it generates 1 million bits. With time division multiplexed circuit switched network, every user has a dedicated channel capacity of 100 kbps or 10 raised to power 5 bits per second. So, the total time taken to transmit 10 raised to power 6 bits is 10 raised to power 6 divided by 10 raised to power 5 bits per second, that is 10 seconds. Circuit switching pre-allocates the link's transmission capacity among the connected users, while packet switching allocates the transmission capacity based on the demand. Therefore, in the packet switched network, if only one user is transmitting data, the link's capacity of 1 Mbps is allocated to one active user only. Hence, the user can send 1 million bits in just 1 second, which is 10 times faster than the circuit switched network. So, the performance of packet switching is better than circuit switching. However, because packet switching gives variable and unpredictable delays, it is often argued that packet switching is not suitable for the real-time services, for example telephone and video conferencing calls. At last, the difference between the switching techniques can be summarized as: circuit switched network or circuit switching reserves channels before the data transfer. Packet switched network or packet switching does not reserve resources before the data transfer. In circuit switching, the idle reserved resources or channels cannot be used by any other ongoing communication. In packet switching, the idle resources are allocated to other ongoing communication. Circuit switching does not involve waiting at the switches. In packet switching, the output queues can grow if the incoming data rate is more than the link's transmission capacity. Circuit switching is less efficient as idle resources cannot be used by any other sender-receiver pair. Packet switching is more efficient than circuit switching. Circuit switching is suitable for real-time services, for example telephone and video conferencing calls. Packet switching is not considered suitable for real-time services as it involves variable and unpredictable delays. Circuit switching is connection-oriented. Packet switching is connectionless. Circuit switched networks can support less number of users simultaneously. Packet switched networks can support more users simultaneously. Circuit switched network allocates dedicated transmission rate for each connection. Packet switched network allocates variable transmission rate based on the demand. If you have learned something from this video, then please like this video. Share this video so that more people can learn. Subscribe to Tech Terms if you want to learn more and turn the notification icon on. Thanks for watching.